multivariable linear systems. All right, so 7.2, we solved multivariable, but we only had two variables. We had two variables and two equations. Well, in this section, we're going to have three variables. I think we'll even do one with four variables, at least in the homework I know there is one. And in order to solve a finite solution with three variables, you have to have three equations. And if you have four variables, how many equations do you think you got to have? Yep, you got to have four. Four variables, four equations. All right, so let's start with a really basic one. X minus y plus 2z equals 1. Y plus z equals 3. And z equals 2. All right, so in this case, we are going to solve these this system of equations. So let me just tell you real quick, when I'm solving these, I always label them. I'm going to label them 1, 2, and 3. And I put a circle around them to differentiate between numbers in my equations and my labeling. All right, we're going to use both. Actually in this one we're just going to use substitution. But in this section we're going to use both substitution and elimination. We have to use both methods in this case. All right, so in this one's the reason I said this one is a really basic one is because do you notice already that z is equal to 2? It's a finite solution. Z will never be anything but 2 in this system. So that means that I can go use substitution and jump and plug equation 3 straight into equation 2. So if y plus z, which we know must be 2, is equal to 3, that means that y must be equal to 1. All right, well, we've got z and we've got y. All we need left to find is x. So we can plug both y and z into equation 1 and solve for x. So x minus 1 plus 2 times my z is 2 is equal to 1. All right, let's just solve this. This is a basic algebra. So we get x plus 3 equals 1, and then x is equal to negative 2. So our finite solution here is, we can put this in coordinate form, negative 2, 1, 2. All right, so we have a solution. You can actually graph in 3D. This is a three-dimensional, and this would be where these three equations intersect. All right, so let's solve one that is a little harder than that. All right, so let's just say we have this system, x minus 3y plus 2z equals 1. 2x minus 5y plus z equals negative 5. 3x plus y minus 2z equals negative 1. All right, this is our system. Let me just double check, make sure I didn't write anything down wrong because that'll just throw everything off. All right, looks good to me. All right, so I'm going to label them. Remember, I always label them. 1, 2, and 3. The harder these get, the more helpful you'll see the labeling becomes. All right, so we have, again, I told you we have to use both elimination and substitution. The way we start off with elimination. So your first step is to pick two equations. If I was going to write steps, I would say pick two equations. Doesn't matter which two. And eliminate one variable. And it doesn't matter which variable. You get to pick in the beginning. I always look for whatever, lowest hanging fruit, what looks the easiest. So I'm looking for additive inverses. Additive inverses, remember we did that in section 2, I believe. I noticed, maybe it was 7.1. So I noticed that my z's in equation 1 and equation 3 are already additive inverses. So the least amount of work I have to do, the less chance I have of making a mistake. So what I'm going to do is I'm going to take equation 1 and add it to equation 3. So 1 plus 3. I also write my steps in the side so that not only do I know what I'm doing, but if I'm grading your paper, I can follow what your steps are. All right, so this is my equation 1. I'm going to write equation 3 underneath it. and I'm going to add them together. So this gives me 4x minus 2y, my z's cancel, is equal to 0. All right, so I label my new equations I create little a and little b. If we have 4 variables, I may have to have a little c as well. All right, so my next step. So after, this was the first one, is to pick 2 equations and eliminate 1 variable. So my next step would be to take the other equation. So here I picked 2 equations. So I need to pick, I don't want to say pick, I'm going to say take, or use. Use the other equation, the one I have not used yet, plus one of the other 2, plus one extra, or one more. And it doesn't matter which one I use. And I'm going to eliminate the same variable I eliminated in the first step. Oops, that's not eliminate. Eliminate the same variable. And it's very important I pick the same variable, or otherwise it's not going to help me. So I eliminated z with 1 and 3, which means I have to use equation, hopefully you know we got to use 2, and I have to eliminate z. So in order to do that, I can pick either 1 or 3 to go with it. There's not really an easier one. I'm going to pick 3, and the reason why is because 3 is a negative and 2 is a positive z. That means I won't have to multiply through by a negative, which makes it a little nicer. Not a whole lot nicer though. So if I took equation 2 and multiplied through by the constant 2, that will give me a positive 2z, which is the additive inverse of 3. So I'm going to take my equation 2, multiply by 2, and then add it to equation 3. So let me write out my steps. 2 times equation 2 will give me 4x minus 10y plus 2z equals negative 10. Adding equation 3 to it, 3x plus y minus 2z equals negative 1. I'm going to add them together. That gives me 7x minus 9y, my z's cancel, is equal to negative 11. Can you guess what I'm going to call this equation? Hopefully you guessed B. All right, so now notice I have equation A and equation B. Now that goes back to 7.1. I can solve those two. I have 2 equations, 2 variables. I can eliminate one of them and solve for a finite solution. So how are we going to do that? I got to get rid of one of the 2. I don't see one as being easier than the other. You can either do substitution or elimination. It doesn't matter. I tend to do elimination. If I were to do elimination, let's just say I want to get rid of my y's. I just kind of picked it arbitrarily. I need to multiply equation A by, I'll multiply through by a negative 9. And then I have to take my equation B and multiply through by a positive 2. This is how I create additive inverses in the y variable. So negative 9 times 4 gives me negative 36x. Negative 9 times negative 2 gives me positive 18y. And then 0 times negative 9 gives me 0. All right, in equation B, I have to multiply through by 2. 7 times 2 is 14x. Negative 9 times 2 gives me negative 18y. And then negative 11 times 2 gives me negative 22. All right, so my next step is to add them. That's what I said I was doing here. Multiplied through by constants to create additive inverses, then I add together those equations. So I get negative 22x, y's cancel, is equal to negative 22, which makes x equal to 1. All right, so once you solve for one equation, solve for one variable, we have our x. So I'm going to have to take that x and plug it back into something. I'm going to plug it into one of either my a or my b, because that will give me my y. So it does not matter. I'm going to go with A. I'll plug it into A. So I'll have 4 times my x is now determined to be 1 minus 2y equals 0, which gives me negative 2y is equal to negative 4, which means y must be 2. All right, I got 2 of my 3. Can you guess how to get z? Hopefully you figured out that I have to plug in to one of the original equations to get the z. Whoops. All right, doesn't matter which one you picked. I'm gonna go with, I'm thinking number 1. I don't know why. It just looks maybe a little easier. I don't know if it really is though. Number 1 equation was x minus 3y plus 2z equals 1 without plugging in anything. That's number 1. All right, but let's plug in now. We have an x. X is actually 1. We have a y. It's 2. Z I do not know. All right, so I get 1 minus 6 plus 2z equals 1. So this makes negative 5. When I add negative 5 to the other side, I'll get 2z is equal to positive 6, which gives me y is equal to 3. All right, I have all 3 of them. So my solution set, did anyone catch my mistake here? That was supposed to be a z, not an x. Okay, come on, pencil. There we go. All right, sorry about that. So my solution set is 1, 2, 3. X is 1, y is 2. So I wanted to show you another example. It's not much different than what we had before, but just in case you come across one and it confuses you. Let's say we have 3x plus 5y plus 2z equals 0. We also have x plus y equals 0. And our last one is 6x minus 7y plus z equals 2. All right, we still have 3 equations, 1, 2, and 3. And we still have 3 variables in total. It just so happens that equation 2 is missing z. And honestly is actually a little easier than the last one we did. And the reason why is because we've already eliminated that. Remember the very first step where I told you to pick 2 equations and eliminate 1 variable? Well, we already have 1 equation written in terms of 2 variables. 2 is it. So what we need to do is we need to take the other 2 equations, 1 and 3, and eliminate the same variable that 2 is missing. So equation 1 and 3 needs to be, we need to eliminate z. So if we were to do that, pause the video if you want to try it on your own. Otherwise, I'll keep going. I'm going to take 1 and add with it equation 3, but I got to multiply through by negative 2 to give additive inverses. All right, so equation 1 is 3x plus 5y plus 2z equals 0. Equation 3 multiplied through by negative 2 is negative 12x plus 14y minus 2z equals negative 4. Add them together, and I get negative 9x plus 19y, z's cancel, is equal to negative 4. This is going to be my A equation. So notice, instead of creating a B, I'm going to use 2 as though it were, my B equation. So I have A and 2 that I'm going to use to get rid of another one. So 2, this one, I can do it either way, but this one is so nice, I almost want to do substitution. But let's go ahead and do substitution. If I use equation 2, let's just say x is equal to negative y. So I'm going to sub that in. I'm going to plug it in to equation A. So if x is equal to negative y, I'm going to take negative 9. Instead of x, I'm going to write negative y plus 19y equals negative 4. That gives me positive 9y plus 19y equals negative 4. So notice how I still have 1 equation and 1 variable. So this will give me 27y. Oops, sorry, 28. 28. So 28y is equal to negative 4, which means that y is negative 4 over 28, or negative 1/7. Not pretty, but true. All right, so I can take this one and I can plug it into equation 2 here. Well, actually 2 is up here, but it's going to end up being the same. X plus y equals 0. X plus y equals 0. But we know that y is negative 1/7. So x plus negative 1/7 equals 0. That means x must be positive 1/7. All right, so we have x, we have y. Now we need to get z. So I'm going to take either equation 1 or equation 3, and I'm going to solve it. I think I will do equation 3. I don't know that one is easier than the other. So equation 3 says 6x minus 7y plus z equals 2. So if I plug these two numbers in, I'm going to say 6 times 1/7 minus 7 times negative 1/7 plus z equals 2. So this one gives me 6/7, and then this will give me plus 1 plus z equals 2. So let's go ahead and combine these two. This will be 13 over 7. Combine it into an improper fraction. Plus z equals 2. So subtract 13/7 from both sides. Z is equal to, so don't forget, so 2 times 7 is 14 over 7. That's how we convert 2 to a fraction. Minus my 13/7. Z will give me 1/7 as well. So it looks like my solution set is positive 1/7, negative 1/7, and positive 1/7.